Hello guys, today we'll be solving LC.48 rotate image. So let's understand the question first. So we are given a 2D matrix and we have to rotate it by 90 degree. So what does the rotation here means? Yeah, as per the question, we have an input matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have to rotate this by 90 degree. Now let me just rotate it. So after rotating, what I get, like 741 in the first row, 852 in the second row, 963 in the third row, right? This is what we have to do. And yeah, now let's think how we are going to approach this problem. So this was my first approach. So what I was thinking is I was writing down the old position and the new position. Like this element, the position of the one is 0 comma 0 initially. Now this has to be updated to 0 comma 2. You can see one moved from this position to this position and 2 moved from here to here. So what is the old position of 2 is 0 comma 1 and 1 comma 2. I was, after noting down all the old and new position, I was trying to find out some correlation, like some kind of pattern here so that I can write the logic. But after spending enough time, I understood that there is no way we can directly find the new position of the element and we can do the swapping process. So finally, I have concluded that there is no direct approach. Instead, we have to do some kind of transformation to the input matrix and then reach the final solution. So A is the input matrix that we have and C is the final goal, like after rotating 90 degree. There should be some kind of intermediate form from which we can reach the last stage, like the final output. So let's look at that solution part. The trick here was we have to find the transpose of the input matrix from which we will be able to arrive the final solution. Here I have said that we have to modify this to an intermediate stage, right? So that modification is transpose. So what does transpose of a matrix actually say? The transpose is nothing but we have to the columns of the input matrix will become rows or vice versa. Here you can see in the first column the elements are 147 and second column has 258. Now this will be changed to the rows in the transpose matrix. Like 147 you can see in the first row, 258 you can see in the second row, and 369 in the third row. So what happened here is the columns have been changed to rows. So now we have found the transpose of the input matrix. What are we going to do next? Yeah, now we have the transpose matrix. Now it's very simpler. We just have to reverse all the elements in the rows to get the final answer. Now, the first row was 147, which we got in the previous stage. If I just reverse the elements here, I get 741. And 258, if I reverse it here, I get 852. And same for 369 as 963. Now we have actually rotated it 90 degree. Let me just rotate in a reverse manner so that we can find it. Yeah, here you can see, right? It is 1, 2, 3, 4, 5, 6, 7, 8, 9. This has been rotated and we got the final output 741. So it's just a two-step process where we have to find the transpose first, followed by reversing the elements in each row. Now let's get into the coding part. Let me store the number of rows in each matrix in m variable. As discussed, let's find the transpose of the input matrix first. So how am I going to find the transpose? Here you can see uh, the columns have been changed to rows, right? Or or we can also say like rows have been changed to columns. If you observe carefully here, the diagonal elements always stay unchanged. 159, the position of the diagonal elements will always stay unchanged. And 2 has been swapped with 4, and 3 has been swapped with 7, and 6 has been swapped with 8, right? That is what we got in the final transpose matrix. So the same thing I'm going to do now. Now what I will consider is I will consider only the upper right triangle, right? The upper half of the matrix, the right triangle. Next, what I will do is now in the upper right of triangle, I can see 1, 2, 3, 5, 6, and 9. Now I will swap 2 with 4 and 3 with 7 and 6 with 8. The position of 2 here is uh, 0 comma 1, right? This is going to be swapped with the element that is present in uh, 1 comma 0. So the row have become column and column have become row. We just swapped it. And what is present in 1 comma 0? It is 4. We can just validate it here. And I told 3 will be swapped with 7, right? The position of 3 is 0 comma 2, and this is going to be swapped with the element that is present in 2 comma 0. So what is present in 2 comma 0? It is 7. So this is how we are going to do it. And we will just consider the we will since we are swapping elements with the lower half of the triangle, we can just consider the upper right triangle. Let's do the same here. Okay. Here I'm assigning j to I and j is less than m. Why j to I? Because for the first row I have to start from this column. For the second row I have to start from this column, right? So second row is the index of the second row is 1, and where am I starting? I'm starting it from the j1. So that's why I'm assuming for every column traversal I'm starting it with the value equal to I, that is rows. Now let's do the swapping process, like a 3 line of code. Assigning one element to temp and doing the swapping process. So yeah, we know we have to swap matrix of I of j with matrix of j of I. So I'm storing matrix of I of j in temp and assigning matrix of j of I to I of j, then temp to j of I. So this is simple. Next, let's reverse the columns as discussed. Reverse process. So each rows I have to reverse, right? Uh, the reversing elements in an array is much simpler. Like what I will do is I will reach till the half elements in a row, and I will again do the swapping process. Like 1 I will swap the last element, 4 stays same. Let me just give you one more example to make this much clear. Let's say there is 1 comma 2 comma 3 comma 4 comma 5. Now if I want to reverse this array, what I will be doing is I will just do traversal till the middle element. Now when I am in the first position, like when I'm at element 1, I will swap this one with the last element here, and when I'm at the position 2, I will swap with the second last element, that is 4. And when I'm reaching the middle element, like nothing has to be done. Even if we swap the middle element in the middle, it again stays 3. So this is what I'm going to do now. That's the reason I'm just traversing till the middle element, like m by 2. Now same swapping process. So why it is m minus j minus 1? As I said, for the first element, I have to pick up the last element here, right? That is 5. So let's the index of the element 1 here is 0, and the index of the element 5 here is 4, right? What I'm doing is m minus j, like m is equal to the size, that is 5 elements. So we have like 5 elements in an array, and subtracting this with the current j. So the current j value is 0, that is pointing to one element. 5 minus 0 minus 1 gives us 4 as expected. Now I am swapping the element at the 0, like 0 position, with the fourth index. Next, when I am at the second position, let's say uh, yeah, let's say I'm at the position I equal to 1. Now the element at the position 1 has to be swapped with the element in the position 3, right? Let's try whether this works or not. The number of elements stays as 5, and now the j index has been 1, and 5 minus 1 minus 1 gives us 3. Yeah, the element at the index 3 is 4. Now 2 is going to get swapped with the 4. 4 and 2. Yeah, this has been already swapped in the previous stage. Okay, now we got the reverse of the particular row. Now, yeah, we don't have to do anything. We just want to modify it in place. The brute force for this solution would be creating a new uh, 2D array and then assigning the value as required. So I just shared here the optimal solution.